Are we ready? We're going to be looking at the inverse trig ratios today. And so on your calculator, if you locate your sine, your cosine, and your tangent, on mine, right above the sine is sine -1. Can you guys see that? Above cosine. So those are the inverse trig functions. And what they do is, if you know a ratio of a pair of sides, you can use the inverse trig function to get back to the angle measure. So the inverse helps us find the angle measure, whereas the straight trig function helps us find the side measure. Because the ratios are consistent always, a specific ratio, a specific relationship between the opposite and hypotenuse will always result in the same exact angle measure. Again, if I know that ratio, I can use that inverse key to get the angle. So let's just refresh quickly from yesterday, all right? First of all, let's look at this triangle. What is this triangle, or what special kind of triangle is this one? 30, 60, 90, how do you know?
Because double 8, hypotenuse 8 to the third 3.
Right. That side relationship, the ratio of the sides put together, will always be the same if it's a 30, 60, 90. So the angle opposite, or the side opposite the smallest angle will always be half the length of the hypotenuse. Did you guys need something? I can't help. Okay. So if I am looking for the sine of x, and I go 8 opposite over 16, I will see that relationship when I reduce it down. The sine relationship in a 30-60 triangle is 1/2. The cosine relationship has something to do with that square root of 3. So when I put the cosine, so again, x is my angle, I have my opposite, my hypotenuse, and my adjacent. We're looking at the SOHCAHTOA. The cosine of x is the adjacent over the hypotenuse. That would be 8 times the square root of 3 over 16. That would reduce down to the square root of 3 over 2. That is the relationship between, or the ratio for the cosine of a given angle in a 30, 60, 90 triangle. Then I go to the tangent, and the tangent is opposite over adjacent. So I would put 8 over 8 times the square root of 3, reduce that one down, multiply by the square root of 3, multiply by the square root of 3, square root of 3 over 3. That is the ratio, again, for the 30-degree angle in a 30-60 triangle. And those ratios will show up all the time. And again, that's what allows us to get back to the angle. So what happens is, if I put on my calculator, and we'll talk more about this in a moment, but if I put on my calculator the sine inverse, see how it shows up with that little -1? Of 1/2, because that's the ratio, it should give me the angle measure that will go for x. So I hit enter. What shows up? 30 degrees. We already knew this was a 30-60 triangle because we recognized the relationship to the sides, but now we can use our calculator to get back to the angle measures as well. So let's do the next one. Is this a special right triangle? Any relationship that we can see? Square root of 5, but I remember working with square root of 3 and square root of 2, so it's not one of the two that we've talked about. But they still have ratios, so if I want to go to the sine of x, again, remember I look at x and I go opposite Hypotenuse is always across from the right angle. Adjacent is the remaining side. What is the sine of x? Anybody? Yeah.
4 times square root of 5 over 12.
Beautiful. Can we reduce that?
Yeah.
Okay.
Square root of 5 over 3.
Perfect. That's a square root. Let me rewrite that. Square root of 5 over 3. How about the cosine of x? Can anybody give me that one? 8 over 12. Can you reduce that? Perfect. Okay. How about the tangent of x? Can anybody give me that one? 4 times the square root of 5 over 8. Can you reduce that one? Square root of 5 over 2. Okay. Any angle measure that matches angle x will have that same ratio of sides. So again, if I wanted to find out what the angle measure for x is, what I do in my calculator is do second sine, and I can plug in that ratio. It is the square root of 5. I have to put a parenthesis around it. My calculator won't let me use fractions when I have a square root in it, so I have to use divide. That's just my calculator's finicky. Oh, you guys need to see that, don't you? And then I'll put that divided by 3, and this will tell me what the measure of angle x is. Angle x is about 48 degrees. So we're going to use what we talk about now to find a couple angle values, and then we're going to mix in other types of problems, some angles, some sides, as we work through our assignment today. Okay? So let's work with using our calculator, finding angle measures. We set up all of our ratios using fractions, but every fraction can be turned into a decimal. And so if I want to find the sine, or if I want to find angle x, and I know its relationship, its opposite hypotenuse relationship, I will go second sine 0.0175. Enter. That means that this is about 1 degree. Do you guys agree? Did you guys get that? Okay. About 1 degree, so x equals 1 degree. I've only done sine up to this point, but I can use the other trig functions as well. So I'll use the cosine for the next one. I just have to do the cosine inverse of that decimal, 0.2756. Hit enter, and that makes 74 degrees. So x here is 74 degrees. Anybody having an issue on their calculator plugging that in and getting that value? Okay, so some of you, first of all, make sure that you are in degrees and not radians. And then also make sure that you're using the inverse key. Do the rest of them here. How about number, or the next one? What do we get? X is 76 degrees. Does anybody disagree with that one? What's that? The one underneath it is the same thing because that's the exact same value. Okay, how about this one? 35 and 10? Great. You guys okay with that? Just a calculator. So now let's do the math with it, okay? So if I want to find the measure of angle A is the unknown. So I'm just going to put like a little unknown thing there. That's what I'm questioning. That's what I'm trying to find. The reason why I like to mark it is because, remember, the opposite side will change depending on the angle that you're looking at. So here, if I'm interested in A, across from A is my opposite. The hypotenuse is the one that's across from the right angle. The remaining side is the adjacent. I know the opposite and adjacent sides. Which trig function will I use? Tangent. Because again, it goes so, ka, toa. And I write it both ways just because, to remind you, That SOHCAHTOA is the word game that we play, or to help us remember, but what it works out to is sine is equal to the opposite over hypotenuse, cosine is the adjacent over hypotenuse, tangent is the opposite over adjacent. So I choose tangent because I know the opposite and adjacent. So I say the tangent of A is equal to 4 over 10. I can reduce that, but I don't need to because I'm using my calculator. So when I go here, I say, I want to figure out what A is. Second tan 4 divided by 10, because that's what a fraction is. Or I can use fraction key if I want to, but it's just divide. It doesn't care how I plug it in. I hit equals, and I get 21.8 degrees. So measure of angle A is 21.8 degrees. Okay. I'll pause and we'll take a look. So the measure of angle A, I put a little mark in that corner because I know that's the one I'm looking at. I label the opposite. Then I find the hypotenuse and then fill in the adjacent. And so from the angle A that I'm interested in, I have the adjacent and the hypotenuse, so which trig function will I use? Cosine. So the cosine of A is equal to 14 over 20. So in my calculator, it's cosine inverse of 14 divided by 20. Get my answer. I got 45.6-ish. Good? Anybody have a disagreement? Feel all right? Any questions? Okay. So let's do a couple more examples. These are not given with vertices labeled in a triangle like the last ones, but instead they indicated the angle of interest with an X in the corner. So I'm going to work it the same way. The angle of interest, I'll start by finding the opposite side. The hypotenuse is always across from the right angle. The adjacent is the one that's missing, or is the remaining one. I use my knowledge of SOHCAHTOA. And I take a look at what I have. The adjacent one is the only one that doesn't have a mark. So I will use opposite and hypotenuse. That's sine of x equals 9 over 10. So the sine inverse of 9 divided by 10 will give me my angle. I got 64 degrees, 64.2 degrees-ish. 64.2 degrees. How are you guys feeling? Good? Okay, I'm going to have you try the next two, see how you do. Try the next two on your own. I'm going to pause this, then we'll reevaluate. The work is all set up there for these next two. I just need you guys to help me with the answer. Can we get an agreement on an answer for cosine inverse of 11 divided by 12? What do we get? 23.6. Does anybody else agree with that? 23.6. We all agree? Great. 23.6. How about the next one? The sine inverse of 17 divided by 18. Bring it. 70.8. I see some head nods. Sorry. 70.8. That's supposed to be an 8. Good? Okay. Here's the setup for the last two. Did anybody get answers? Was anybody ambitious? And go ahead and get the, yep. 22.5. Does anybody agree with that? 22.5. I see some head nods. Okay? And finally, yep. 55.9. Do I have any agreement on that? 55.9. Good. How do you guys feel? Pretty good? Let's take it to the next level. Remember yesterday in part of your homework assignment, you were solving a triangle. We're going to solve a triangle again. It says, find the value of A, B, and what the heck is this? It's not. It's not. It's not. This is a Greek letter. It's called theta. And oftentimes in math, they will use Greek letters to represent angles, especially when we work through trig stuff, okay? So if you move on beyond this class, you will see this a lot. You actually see it in chemistry and physics and things like that as well. Alpha, beta, theta, this is theta, okay? And so it just is a variable. You could replace that with the letter X if you wanted to. It means the same thing. But I'm going to keep it as theta because I want you guys to get comfortable with this. So I have to find all of these things. A, B, and theta. And I have to use any method possible to do it. Just because I wrote A first and A was listed first does not mean I have to find A first. All right? But we'll use any bit of anything we've done in math so far to work our way through to get these answers. Can anybody get me started? Does anybody have an idea on how to do anything up here?
You can find theta by doing 180 minus 180.
Great. What do you end up with? 70 degrees. So I could put 70 degrees in that spot. Super. All right? How about A and B? I don't have enough information to do Pythagorean theorem, do I? This is not a special right triangle, so I can't use any of those rules. How do I know it's not special right? What do these angles have to be one of our special ones? 45 and 45 or 30 and 60. This is 20 and 70, so it won't work. So what's my other option? What did we do yesterday? Set up our SOHCAHTOA, set up a trig function. So I'm going to start with the angle that was given. That one's marked in here. So I'll go across from 20, that's the opposite. The hypotenuse is across from the right angle. The missing one is the adjacent. I want to start by finding A. A is the opposite. I can't use opposite and adjacent because I'd have two variables in my problem, so the only thing I can use is opposite and hypotenuse. Which one uses opposite and hypotenuse? Sine. So I would do the sine of 70, or sorry, of 20, because that's the angle that I drew from. The sine of 20 equals A over 28. Refresh my memory, how do I solve? How do I solve? Yeah. Yep. I just do 28 times the sine of 20. 28 times the sine of 20. And I get let's go 9.6-ish. Okay? So now I know that is roughly 9.6. Now what are my options? I still need to find B. What could I do? Yeah. I could do the cosine. So I would set up the cosine of 20 equals B over 28, and I'll solve it the same way. That'll give me my B value. 28 times cosine of 20. I got 26.3. How's that sound? Good? Great. Okay? So we've used the sum of all the angles in a triangle equal 180. We've used SOHCAHTOA. We've, in the past, used special right triangles. What was another thing that we used? I should have reminded you guys to pocket your phones. I don't think I should have to remind you that daily, but I see a lot of people taking a look at their phones, so why don't we take a pause now. You guys can get your phones in the put away. Okay, we're back to looking at our notes again. So I went through, we did special right triangles, right? We did SOHCAHTOA. What else did we do? Oh, sum of all the angles in a triangle is 180. But what was another thing we worked on so far? This chapter. Pythagorean theorem. I can still use the Pythagorean theorem. Is the Pythagorean theorem going to help me on this triangle? Yes, it is. This should be marked as a right. Please put that in there. But if this is a right triangle, how can I find A? Yep. Perfect. A squared plus 10 squared equals 12.5 squared. So A squared plus 100 equals, this is going to end up being a decimal, 12.5, 156.25. Then I can do my math. A squared is 56.25. Now here's the thing. Up until now I've said simplify the radical. We do that if the number that we put in is a whole number. If the number that we put in is not a whole number, if it's already a decimal, then I'm okay to have a decimal answer. So I'm going to go ahead and put 56.25 in here. Oops, I need to do square root of 56.25. And it comes out to be 7.5. So 7.5 is my answer for that. So I found A. A is 7.5. Now I need to find X and theta. So my job here was to find A and X and theta. A is 7.5. Now I need to come up with a way to find X and theta. Can I use the sum of all the angles in a triangle equal 180 here? No, because I have two unknowns. So I'm going to have to start with a different way. That's where what we learned today comes into play. I just have to decide which angle I want to find first. Should we find X first? Great. I saw a nod for that, so we're going to find X first. So X is the one I'm interested in. I'll go and label the opposite. Across from the right angle is the hypotenuse. The remaining one is the adjacent. I have all the sides filled. That means I can use the trig function of my choice. If you had to pick a favorite, would it be sine, cosine, or tangent? Sine, great. For no reason other than it's the first one usually. Okay, so this would be the sine of x is the opposite 10 over the hypotenuse 12.5. You could do this same job choosing cosine or tangent as well. There might be a little bit of a rounding difference, but they all should get you pretty close to the right angle. So we chose sine, so I'm going to do sine inverse of 10 divided by 12.5. So second sine 10 divided by 12.5. I got 53 degrees. Seem reasonable? We'll just go to the nearest whole degree just to make our life a little bit easier. All right, now I have to find theta. Because I already found x, I don't have to do a trig function or trig problem again. I could relabel the adjacent or opposite adjacent and hypotenuse on theta, But now I do have two angles of the triangle, so I can go ahead and figure out theta by just doing 180 minus 90 minus 53. And I'll get my final answer that way. It looks like it's going to be 37. Great, okay? So again, just because one time in one problem you use one method and another time you do another method, pick and choose appropriately for each triangle. And there's not exactly one right way, so you might be able to do it one way and the person next to you does it another way, all right?